So this page is going to review a number of things. First, we want to graph this function. To graph f of x, we know that our graph is going to make a curved parabola, a half parabola up and off to the right. So to graph this, I'm going to start at -3, 0. From there, I'm going to go up 1 and to the right 3. From there, I'm going to rise up 1 and to the right 5, and I could continue. We see that our graph is a curve that starts here and rises and goes up and to the right. If I were to express my domain, the domain of this function is going to be from that x value, -3, and it includes -3, goes to infinity. From there, my range, I see that my range is all my y values. It starts at 0, and it's forever increasing, so to infinity. Okay. Now we need to graph its inverse. In order to graph the inverse, I need to first find the inverse. So to find the inverse of my f function, I want to rewrite this as y equals the square root of x plus 3. And I want to go ahead and switch out my x and y values. I know that those are going to trade places. So I want to solve x is equal to the square root of y plus 3. Here, in order to solve for x, I'm going to square both sides. I'm going to have x squared is equal to y plus 3. And then I'm going to minus 3. So I have y is equal to x squared minus 3. Okay. For this, I want to take a look here. My original function here had the square root of y plus 3. Okay. This input here has to do with y, and our y's have to do with our range. So notice our range here was from 0 to infinity. My y now becomes my input, and so that means here that once I reverse these, my domain can only be x squared minus 3 here for x values that are greater than or equal to 0. So now when I want to define my inverse function, that's going to be x squared minus 3. And I have to specify for x values greater than or equal to 0. And I want to go ahead and graph this. So I know here that my vertex is going to be down 3. From there then, I'm going to rise up 1 into the right 1, up 3 into the right 1, and up 5 into the right 1. I'm going to go ahead and connect this. It's going to give me that U-shaped graph, but it's only going to give me one side of that U shape. Notice I'm only doing for x values that are greater than or equal to 0. I need to state my domain and range. For this red function, my domain is going to be x values that go from 0 to infinity. And then my range is going to simply be from this minimum value here, which is -3, and going up to infinity. Now if I want to verify that two functions are inverses of each other, I want to check the composition of f and the inverse of f of x to see that that gives me x. And I also want to check that the inverse of f composed with f of x is also x. Okay, so let's take the first one here. F of f, or the inverse of f, means that I'm going to take this inverse of f and I'm going to substitute it into the f function. Okay, this then is going to tell me that f of the inverse of x is equal to the square root of, I'm putting this value in, so x squared minus 3, and then that's what the inverse was, and then plus 3. If I simplify this, it's going to be x squared minus 3 plus 3 is simply equal to the square root of x squared. which does in fact equal x, since we're talking about just x values greater than or equal to 0. If I go back, and now I want to take the inverse of my f function. So I want the inverse of f of x. This then is going to imply that I'm going to take my f function and I'm going to substitute it into my inverse function. So my x squared is going to be the square root of x plus 3, that quantity squared, and then minus 3. The square root squared is going to just leave me with x plus 3, then minus 3. This also just gives me x. So I've now verified that both of these functions give me, both of these compositions give me x, and if both of them give me x, then I can indeed verify that my functions are both inverses of each other.